Check, check, check. Yes. I hope I am audible now. Good morning, everyone. Check, check. Yeah. So the indicator is showing that my voice must be reaching. Let me see. Achha, it is very low. Yeah, it was very low. Now it should be audible. Check. Yeah. Okay. 11 of you are there. Am I audible, by the way?
Yes, sir, you are audible.
Okay. Okay. Now I can hear you. Harish. Thank you, Harish. Yeah, so we had a little bit of a break, unplanned break, because of the programs and other things. Now is also uh, what do we call Navratri? Yeah, Navratri begins today. So fortunately, we are still having all the sessions. So we'll have this week's session. Yeah. So you remember what we were discussing last time? Something called as skewness. Skewness. Anybody? Everybody remembers what was skewness?
Yes, sir.
Yeah. So yeah. So anybody would like to define or recollect something from there? We also used box plot in analyzing skewness.
So should we say in brief what skewness is?
Yes, yes, please.
So it's a property of a frequency graph not being symmetrical.
Yes, not being symmetrical and inclined to one side.
Yes.
Yes. So skewness can be positive or negative. Positive means it is right skewed, and right skewed means the tail is towards right. The tail. Yeah. So basically, yes. So that is a very quick revision of skewness. And formulae, we had three different formulae. I hope you remember the three different formulae. One was based on moments, which we called moment formula for skewness. That was actually, in a way, that was the simplest one, logically at least. So I'll share this. Yeah. So these are the things we discussed. So this is the basic formula or moments formula for skewness. This one. Yeah, I was watching the recordings. I realized that unless I draw some marks, I mean, here I am rotating my pen over a portion, but that is not visible in the video, and I think that is not visible to you people also. So whenever I want to highlight something, I'll actually draw some mark. So right now I'm drawing a yellow highlight. Yeah. So this is the formula for skewness, which is based on the moments. In a way, this is the simplest formula. Then we also have Pearson's skewness coefficient, which is this 3 times mean minus median divided by standard deviation. And then we had Paul's formula, which can be better understood by uh, visualizing the box plot, yeah, which is also very simple. Q1, Q2, Q3 are first quartile, second quartile, and third quartile. And I think one of you asked how to find quartiles. I hope you write that out in between. We have so much time. You took somebody's help, one of your classmates' help to figure out what is how to find first quartile, second quartile, and third quartile. It is very simple. So given a set of data, we arrange that in ascending order first, then divide into two, the midpoint. Yeah. Then the first half we again divide into two, finding the midpoint, and the lower half we divide into two, finding the midpoint. So this one is first quartile. The middle one is of course second quartile, which is also the median of the entire data. Q2 is also the median. And
So
yes, screen is good. Yeah.
Yes, sir. So you were saying that you divide the whole box plot first and you find the midpoint, and
To the box plot, I drew a representation. These are all numbers. Okay. I mean, let me take numbers actually. So 5, 10, 12, 14, 20, 25 like this. So we have a set of numbers. These are 6 numbers. So we will divide these into 2 halves. Yeah. These are already arranged in ascending order. So we will divide this into 2 halves. So the midpoint will be here. What will be the midpoint? Average of these 2 numbers. So average of these 2 numbers is 13. Yeah. Is it clear? So
yeah,
the whole,
yes, sir, yes.
yeah, so whole data we divided in the middle. Now there is the upper half and lower half. The upper half also we will divide into equal parts. The midpoint at which we can do that is this point 10, this number 10. So above 10 we have half, below 10 we have half. So 10 is the midpoint. Okay. And in this lower half, we can do the same. We can divide the lower half into 2 equal parts at this point 20. So below 20 there is half of the data, above 20 there is half of the data in the lower half. So 10 becomes the first quartile, 13 becomes the second quartile, which is also the median, and 20 becomes the third quartile. It is the simplest logical way. There is a mathematical formula also to do this. And when we have group data, actually one session specifically we will keep for grouped data. Group data means the data with class intervals which we studied. All this is ungrouped data. So each individual data we can see. Many times data will be given in a group way. Group data will be given. So like this, 0 to 10, there are so many numbers. Frequency will be given. There are say 2 numbers. 10 to 20, there are so many numbers. 4. Yeah. So it is group data. 20 to 30, there are 3. So these are frequency. Dealing with the old reports or some confidential reports where anonymity of people have to be maintained. People do not want to reveal their identity. Still, we will have this kind of data. The exact data points will not be revealed to us, but the class intervals and their frequency will be revealed to us. So we need to modify what we learned so far with ungrouped data a little bit. Yeah, that modification is quite logical, so you will get that logic very easily. Most of the times it is the midpoint of the class interval which we take to represent this entire data. So we will treat as if there are two fives in that data. So midpoint of this class interval is 5. We will treat that. Yeah. So we will treat that we have two fives in this data, two midpoints of this class interval in this data. Similarly, midpoint of this class interval is 15. We will treat as if there are four 15s in the data like that. Yeah, so you don't have to worry about these modifications as of now, although I hope you understood the logic. क्लास इंटरवल को क्लास इंटरवल के मिड पॉइंट से सब्स्टिट्यूट कर देंगे और बाकी का ज्यादातर चीजें बाकी की वैसी ही रहेगी फॉर्मूले में. Okay. So deliberately I mean we have not discussed the group data initially as of now till now. Yeah. Yes. So this quartiles, how to find quartiles, you understood?
Yes, sir.
Okay, so these quartiles only are used in Bowday's formula for skewness, which is first quartile plus third quartile minus twice into median divided by the difference between third quartile and first quartile. Coincidentally, this difference between this is also called the interquartile range. Interquartile range, IQR. If you remember, to find the whiskers, the endpoints, these endpoints, endpoints of these whiskers, we used interquartile range. Okay. This lower end, how do we find the lower end? This is Q1, that is the first quartile, minus 1.5 into this interquartile range. You can write interquartile range or you can write Q3 minus Q1, both the same thing. And how to find this upper end of the whisker? Q3 plus 1.5 into interquartile range, that is Q3 minus Q.
So 1.5 is the skewness level?
No, it is the constant which is chosen. Yeah. So we have to stop the whisker somewhere, right? So conventionally, it is chosen to be 1.5 times the interquartile range plus the third quartile will be the end of this whisker, and similarly, first quartile minus 1.5 times the interquartile range will be the lower end of this whisker. So it is a convention, it is not a universal phenomena. I mean, yeah, it is not a universally natural phenomenon. Of course, it is universal. That is why we accept that. Yes. Yeah. 1.5 is nothing naturally occurring. It is not like a gravitational constant. Yeah. So it is a convention. ये चूज किया गया है और सबके लिए एक्सेप्टेबल है कि ये वाला जो एंड पॉइंट होगा वो इसी तरह निकाला जाएगा और जो लोअर एंड पॉइंट होगा वो इस तरह से निकाला जाएगा. सो दिस इज ए कन्वेंशन एक्सेप्टेड एवरीवेयर. Like convention means how you write A in English alphabet, either like this or like this. Yeah. So there is yeah. So this is a convention followed everywhere. Like that. Yeah. So these are the three nice formulae to find out skewness. I think I had problem. I mean, problem to solve skewness. Let me see. I have put it down. Put it in the PPT. Just a second. That found a very nice example. Yes, just give me 2 minutes. I'm unable to trace the. Yes, there is a simple problem. Actually, simple problems are more rare. Little bit rare. Yes. So this is the data set. This is the data set given to us. The blanks. So you note down this data in your notebook, and we will try to find the skewness of this data. So this is the data 3, 13, 11, 11, 5, 4, 2. Okay. Target is to find the skewness of this data. What do we do? So we have individual data points.
So there's a lot of disturbance from your mic.
Check. Is it clearer now?
Sir, I don't think it's yours. I think Parikshit's mic is on. Sound coming from his mic.
Yeah. Please mute your mic. So I hope. So this is the data set. I hope the screen you can see.
Yes, sir.
Yes. So this is the data set 3, 13, 11, 11, 5, 4, 4. So you have to be going to find skewness of this data set. So what should we do? What all should we do? Actually, we can use all the formula because the raw data, the ungrouped data is also given. So we can use all the formulae we have studied. Just use the moments formula. Moments formula initially looks the most difficult to use. So let us use that only. Use moments formula. So those of you who are on computer can easily use Excel. Otherwise, also it's not a very big data set, and these are not complicated numbers. Yeah. So all less than number 20 and no decimals, nothing. So by hand also you can try. So first thing is, of course, to do all the calculations, we will need the mean, find the average. Yeah. So mean will be sum of all this. Sum 3, 13, 11, all these divided by how many numbers are there? 7 numbers. So divided by 7. Yeah. Let's see. We can first calculate the total also. That will be the total. And then mean. Then you can put more columns here. So what all do we want to find out? We basically want to use this formula, right? Or let me write it again because it has been a while since we discussed that last time. X U. Oh, sorry, not 1 by 2, 1 by n. Is this correct or did we miss something? Let us go back and check. In your notes also, you go back and check.
Sir, it's correct.
Yes. Yeah. So to use this formula, what all do we require? We need, of course, x bar. X bar is this mean. Yeah, x bar is this, and then we need to calculate summation of all x minus x bar, xi minus x bar we can call. So we can have a column here. So xi minus x bar, I'm writing like this. So 3 is the xi here, minus x bar is fixed 7, 3 minus 7. If you want, you can write 7, or you can just put your cursor here and click here. But one thing you have to be careful while using Excel is now you have to fix this. Yeah. So if you click before the number, before this reference, and click F4, F4. That is F4 like this. The dollar sign appears, and now this number is fixed. Even if we drag this every time, it will take 7. So here also it has taken 30 minus 7. Going down, it has taken 11 minus 7. Going down, it has taken again 11 minus the average 7. Like this. Here it has taken 5 minus 7. Yeah. So all the xi minus x bar we have, we can sum that. Yeah, because we need summation of those. No, we need summation of cube of those. So first we should cube that. Yeah. So how should I say? Cube of xi minus x. So there are some using symbols and other things. You can write it as it looks by hand, as it looks here. But we need not do that in Excel. Yeah, as of now we need not do that. So Q, this will be Q. You can simply multiply the same number twice. The same things you will get if you use the power function, that is power, the number you want to power, and by what power. Here we are using power 3. Cube makes power 3, right? So it will give the same result. So there is a function in Excel for almost everything that will also, this will also give the same results. So right now one way is enough. So we can have this. So now we will sum this. Xi minus x bar, we have all the xi minus x bar. Now we will sum that. So we will sum that. That is total sum of. I hope you are also doing this by hand. Although by hand it will take little more time. Then the numerator is taken care of, and of course is 7 in our case. Here is the standard deviation cube. So standard deviation we have to find out first. And what is the formula for standard deviation? Square root of summation xi minus x bar square divided by n. Okay. So this is the standard deviation. So to calculate standard deviation, we need xi minus x bar, all xi minus x bar and their square. So let us just add one more column. Xi minus x bar to hai. Yeah, we had to calculate earlier. So now square of xi So, yeah. So this multiplied by itself, it will give all the number squares. So like for example here it has multiplied 4 multiplied by 4. Now here it has multiplied minus 3 multiplied by minus 3, which gives us 9. Like that all the square of xi minus x bar we have calculated. Okay. Now what does the formula say? Summation of that xi minus x bar square. So all the xi minus x bar square we will sum. So we will sum. So this is this part. Then to find out the standard deviation, we will divide by n. This 122 divided by n. N here is 7. Yeah. Not mean 7. This number of entries. Okay. Yeah. Later it should not cause any confusion. Okay. So here the 7 is n number of points. Yeah. 1, 2, 3, 4, 5, 6, 7. Yeah. Or if you want, because here I can change 2 to 3 very easily. All the things will get updated. But if we have done by hand, it will take some time. So I'm not changing it. That will remove the confusion. If I change it to 3, suppose I do like this, then it will be 7.14. Then that confusion won't be there. Which 7 I am taking here. Yeah. As of now, let's keep things simple. So mean is also 7. Number of data points is also 7, coincidentally. Yeah. So this is actually not our standard deviation. What we have till now calculated is not our standard deviation. Square root of that number will be our standard deviation. Square root of this will be our standard deviation. So standard deviation equal to square root. There is a square root function, SQRT. 17. That is 4.17. Actually, there is a standard deviation function also in Excel. STDEV, standard deviation. Then you select all the numbers here. Standard deviation, all the original numbers here. So it should give us the it is giving a slightly different number. Maybe let's take some assumption. STDEV is the standard deviation. We have taken all the numbers. It's giving 4.5. Yeah. Okay. So yes. So it has taken account of the number of degrees of freedom. Yeah. That we need not consider right now. What Excel has done is, while calculating this, rather than 7, it has divided by 6 and taken standard deviation of that. So accounting degrees of freedom, which maybe we'll discuss sometime in your masters. Yeah. You won't be considered wrong if you write 4.5 as standard deviation in this case. You won't be considered wrong, but keeping things simple, we have followed all the procedure and got standard deviation as 4.17. Okay. So now 4.17 is the standard deviation here. So basically it turns out to be taking the numbers from here. This is the cube of xi minus x bar 120. This is the standard deviation 4.17, and substituting here, so this will give us 1 by n, that is 1 by 7 xi minus x bar whole cube. Summation of that comes out to be 120 here, and divided by the standard deviation 20, summation of that is already considered, and divided by standard deviation here. Standard deviation here is 4.17 cube of that. 4.17 cube of that. So those who have observed carefully now know why these things do not cancel out. So this is Q, and we have taken sum of that. Even if we convert the standard deviation with this formula, if we substitute here, we won't be cancelling out things because it is summation. Summation is there. Yeah. So in your free time today, think about it. Try substituting standard deviations formula here in this formula. You will be tempted to cancel out many things, but you should not cancel out things because both in the numerator and in the denominator also you will have summation. So these are what three numbers you can cancel in denominator and numerator. So these is the summation. So try to think about it a little. Yeah, if you are interested. Otherwise, otherwise it is not necessary to understand as of now. But it will be interesting to think about it. Yeah. So skewness from here you can calculate. So 120 divided by 7 multiplied by 4.17 cube. Yeah. So 4.17 cube will be 4.17 into 4.17, that is 72.76. So here we will have 127 into 72 point, how much it is? 76. 76. Yeah. Now we should get the result in the next step. So it comes out to be 120 divided by 7 multiplied by 72.76. Yeah. So 0.2. So it is 0.23. So this is what? This is skewness. Skewness of what? This data. This data. Skewness of this data set. Is 0.23. This is our final result. Okay. So whenever you are comparing two or more data set, use the same method to find the skewness. Not that moments method for one data set, then Pearson's coefficient of skewness for other data set, and Pauli's skewness coefficient for other data set. Pauli's formula for other data set. Don't do like that. So whenever you are comparing two or more different data sets, the skewness of two or more different data sets. Yes, so somebody has asked what is the unit of skewness. Yes. So this is the formula. From this formula, what a unit could you find? Standard deviation is in the unit of the variable. So suppose the variable is length. So this will have units length q. This will be length q. Standard deviation will also be in length. So this will be length q, and this is n, a number, a constant. So length cube divided by length cube will dimensions will be cancelling out each other. Dimensionality, when you have studied, so length, say centimeter. So numerator's unit will be here centimeter cube. Denominator will also have centimeter cube. So these will cancel out each other, and skewness will be dimensionless, unitless or dimensionless. All right. Yeah, very good question. Very good question to check. Yeah. Who has asked? Let us thank him. Who has asked? Sorry. Devane. Devane. Very good question. Yes. So skewness is 0.23. Is it clear? I hope the other two formulae will be easier for you to use. Bowditch formula and Pearson's coefficient for skewness will be still easier for you to use. Can you do this for Bowditch formula? Don't expect to get exactly 0.23. Yeah. Don't be perplexed or don't think that you're doing something wrong. But remember that whenever you are comparing two or more data sets, use the same formula. If you have used Bowditch formula for one, for calculating skewness for other data sets also, use Bowditch formula. Then you can compare. Try using Bowditch formula. I won't tell anything now. I won't give the process step by step. Yeah, you can take 2 minutes. Yeah, we have time. 10:30 to 11:30 it is. So we have a lot of time. And then we can have a look at kurtosis, which is not very difficult. Just have 2 minutes to use Bowditch formula. I will project the data and switch off my mic and video. All right. So who got what? Check. Yeah, that you can put in chat. 11 is second quartile. Yeah, 11 is second quartile. What after that? Yeah, 11 is second quartile. There is the middle value. Then first quartile. Now, actually, you will have to arrange this in ascending order now. Before finding quartiles, this is not arranged in ascending order. For using the moments formula, we didn't require that. But now you will be arranging that in ascending order. In Excel, you can do that easily. Smallest to largest. This has come in between. This has changed few things, but still, we can ignore most of the things. So now this is in ascending order. Yeah, still 7 numbers, of course. So the middle number is 5. So second quartile is not 11. Yeah, second quartile is not 11. Second quartile is 5. Because first we need to arrange it ascending order. Then the first quartile is 3. And the third quartile is 11. All right. Then the formula, this formula, Q1 plus Q3 minus 2Q2, that will be 3 plus 11, that is 14, minus 2 into 5, that is 10. So 14 minus 10 will be 4. 4 and divided by Q3 minus Q1. So 4 divided by 11 minus 3, that is 8. 4 divided by 8 will be 0.5. Yes, so it is giving a different value almost. Why is this Skewness? But if you are comparing different data set, you use the same formula. Bowless formula, if you are using for one data set, you use the same formula for other data sets also, then you can compare. Here using Bowless formula, of course, we are getting around 0.5. Using moments formula, we are getting 0.23. Okay, so we also realize that there will be a difference when we use different formula. The values we will be getting will be slightly different, but we can still compare if we use the same formula for all the data sets we are considering. Okay. So this is all about skewness. Now coming to kurtosis. Now kurtosis defines, in rough language, it defines the peakedness of data. Peakedness of data. Okay. So one data, suppose, is like this. One data set frequency distribution is like this. And the other data set is like this. Okay. So this definitely is more peaked. Okay. And that implies higher kurtosis. Okay. So now, if it is a very symmetrical, very normal distribution, yeah, very simple distribution with moderate peakedness, then we get a particular value of peakedness. Yeah. Pickedness has three categories depending on the values. Depending on the values, pickedness has, kurtosis has three categories. So we will briefly mention them. Before that, let us discuss the formula to find kurtosis. Yeah, as I said, formula to find skewness and formula to find kurtosis has some resemblance. Yeah. So kurtosis is simply this. Again, 1 by n. This here is xi minus x bar. Now it is 4 to the power 4 divided by standard deviation to the power 4. That is the only difference. Only difference means it changes a lot, changes things a lot. One by n summation of xi minus x bar to the power 4 divided by standard deviation to the power 4. Again, keep in mind that if you substitute the formula for standard deviation, things will not get cancelled out because it is summation. The numerator also it is summation, and the denominator also, when you have standard deviation, it will be summation inside the power expression. Yeah. So it will not cancel out this term. So we have to calculate properly. This will give us the kurtosis. So now kurtosis. Yes, yeah. So somebody has asked the formula for decile and percentile also. That we will discuss. Yes. So I think those subtopics are there. As you find quartile, similarly you can find decile and percentile also. But it doesn't make sense to find percentile to divide the data into 100 parts every time. So we use a formula. Yeah. So we will see that formula in the next session. Percentile and decile we will discuss in the next session. So here let us finish kurtosis. So kurtosis, normal looking graphs value. A graph looks. So this middle one, this white one, I hope you're able to see. This white one, normal distribution. Uh, Normal distribution is a type of probability distribution, and as I keep saying, most of the phenomena, naturally occurring and man-made phenomena, provided we have collected enough data, thousands of data points, the data frequency distribution of that data will be normally distributed. The data will be normally distributed provided we collect enough number of data points in most of the naturally occurring and man-made phenomena. That is why it is also the most popular probability distribution, normal distribution. So the white graph is normally distributed data. Then if the pickedness is very high, it is called leptokurtic. Yeah. Normal distributed data is called mesokurtic, and the value is 3. 3 means the value of this formula. If it is 3 equal to 3, the data is called mesokurtic. If this value is greater than 3, it is called leptokurtic. And if it is less than 3, it is called platykurtic. Not very complicated thing. Okay. So this is regarding the values. So 3 is the ideal number. Yeah. There is nothing good or bad about it. 3 is what is distinguishing the different types of kurtosis. There are three types of kurtosis. Either the data will be mesokurtic, or it will be leptokurtic, or it will be platykurtic. And considering the graphs, they will look like this. Yeah. So platykurtic, if it is much less than 3, वो flat ही लगभग flat ही दिखेगा. Yeah, लगभग flat ही दिखेगा. So as you can see, kurtosis and skewness are not related. What I am saying now is very important. Although we study kurtosis and skewness together most of the time, kurtosis and skewness are not related. Yeah. In polykurtic data can have left skewness, right skewness, or no skewness. A leptokurtic data can have left skewness, right skewness, or no skewness, skewness 0. Yeah, similarly with mesokurtic data. So skewness and kurtosis are not affecting each other or not causing each other. That should be very clear, because that is a common misconception, and many researchers have tried to clarify that by writing good papers. Not kurtosis does not affect skewness. So kurtosis we can calculate for the same data set. You can try out, yeah, for this data set you can try out find the kurtosis, yeah, by this formula. What formula? This formula. 1 by n summation of xi minus x bar 4 raised to the power 4 divided by standard deviation raised to the power. So this is all about skewness and kurtosis. If we want, if there are no doubts, we can also, yeah, of course, in the next session, we will be discussing decile and percentiles. And after that, we can move on to the next unit. All the next unit will not be there in your midterm. Yeah. Yeah. Either you come up with problems, doubts and problems, which we discussed, or we move on to the next unit in the next session, that is next week. Yeah. So tomorrow, hey, Friday, right? Friday, we have a session. Let me check. Yeah, Friday 11:30. Okay. Yeah. So tomorrow, please try to come up with your doubts. Revise. That is how you will come up with your doubts, right? Revise and see where you are not clear. Then ask tomorrow at 11:30. And before that, we will very quickly discuss deciles and percentiles. All right. Yeah. Have a short break of 1 or 2 minutes, and please proceed to your next session, next lecture.
Thank you, sir.
Thank you. Thank you.
Have a nice day.
Yeah, you too. Have a nice day. Thank you.